Hi, this is a review of chapter 1, and I'm going to go through all these different questions. I think the best way to do this would be to try these problems on your own first and let me help you with the ones that you don't understand. I think the worst thing you can do is to follow along and just copy down the answers or just copy them down. The test will be just like this. We'll have different problems that cover all of these different targets. So this is the first one. I'm going to do this one. I think it's a little bit easier. 3 to the fourth. This means this is right being powers is a product of the same factor, 1.2a. 3 to the fourth. We take 3, which is the base, and we write it 4 times. The exponent tells you the number of times, and then you put a multiplication sign in the middle of it, just like so. Okay, and let me do 5 to the fifth. 5 times 5 times 5 times 5 times 5. Let me check, make sure I have 5 of them. 1, 2, 3, 4, 5. Yep. The exponent there tells you how many times you have it. All right, the next one is I can write these following numbers in exponential form. We're just going to write them. Here's the base is 7, and I have 2 of them. So this is 7 to the second. This one here, the base is 9, and we have 4 of them. So it's just 9 to the fourth. All right, 1.2c, I can evaluate these expressions. You put them into the calculator. You would put into the calculator 2 times 2 times 2 times 2. You finally, because it says evaluate, you finally get to write down what is equal to. Well, I'll just do this by hand. 2 times 2 is 4. Here, this 2 times 2 is 4. So I can just shorten it, and this is 4 times 4, which is 16. This one's a little more complicated. 6 times 6 to the third power. 6 times 6 times 6. Well, 6 times 6 is 36. 36 times 6. This is going to be 216 is what that's equal to. All right, so evaluate, you finally get to put them into the calculator. The way you show your work steps on all these is just like I've done here. And I actually would probably just write up here 7 squared, 9 to the fourth, just like that, showing that that's what that is. And evaluate, that's what I would have put into the calculator, so that's what I would put down. All right, number 1.4a, I can evaluate these expressions using the order of operations. All right, well, I'm going to try to squeeze these in here, see if I can get it. Well, first of all, here's my PEMDAS, parentheses, exponents, multiplication or division, then addition or subtraction. And some people call this GEMDAS because you can put in grouping. You get that, so you can see that little helper over there. All right, so let's see if I can go ahead and do this. So I'm going to start off with doing the parentheses. That's what it says first. So this would be 20 divided by 2 times 3 minus 3 squared. So I got my parentheses done. Now look over here. I have to do exponents next, which is over here. So this is minus 9. Just go through and write this as 20 divided by 2 times 3 minus 9. I'm not going to fit it in here, am I? All right, the next one I have to do is, well, I've got the parentheses and exponents done, multiplication and division in the order it appears. Well, this is multiplication, this is division, but the division comes first. So this would be 10 times 3 minus 9. Make a little spot to put this up here. All right, so now I can do the multiplication, which is 10 times 3, which is 30, minus 9, which is 21 for that problem. Okay, this next one, 7 squared minus 12 divided by 4 plus 12. Let's see, I don't have any parentheses, but I do have an exponent here. So let's go to the exponent. So 7 squared would be 49 minus 12 divided by 4 plus 12. Got to write the whole thing out. This is where kids shortchange themselves and miss points by not showing the whole work steps. All right, now the next one. I have subtraction, division, and addition. Multiplication and division come first, so I'm going to do this division. 12 divided by 4 is 3. So now I have 49 minus 3 plus 12. And now I can do addition and subtraction in the order of which they arrive. So 49 minus 3 is 46 plus 12. Just put this over here. 46 plus 12 would be 58. All right. I can evaluate the following expressions. M plus 5 when M is 30. We simply put the 30 in place of the M. That equals 35. All right, this next one, 8s when S is 12. Here's the 8. and I'll put the 12 when they're next to a, when you put the value for a variable in and it's next to something, you should put it in parentheses. That reminds you that it's multiplication. 8 times 12 is 96. So there's evaluating expressions. Now I can write one variable equations for a given situation. Bill washed 7 cars last Saturday. I always take notes when I read it. He charged the same amount for each car he washed. Back this out so you can see a little bit better. For each car that he washed. He earned a total of $84. Write an equation to match this situation. All right, let's see. To solve this one, I would go 84 divided by 7. So that means if I solve it with division, I got to write it with multiplication. So the multiplication, let's see, will be, so $7 times, we're not sure how many cars, equals 84. Now I know the number is 12, but you notice we're not even interested in that. We just want the equation. So this is what I'd be looking for. And then on the test, I'd be looking for you to check your work by 7 cars. This is the number of cars. This is the total earned. Sorry, this is the amount. Get my arrows going to the wrong spot. See, that's why I checked it. This would be 7 times, this would be 7 cars here. And this is the cash or the money he charged. Could even change maybe that variable to M for the money. Or his earnings or his charge. I guess we use C for charge. Charge per car. All right, makes sense. 7 cars, so much charge per car, looks like $12 equals a total earned. There we go. Let's take a look at another one. Jack worked 4.5 hours on Monday and 6.5 on Tuesday. He worked a total of 16 hours. Okay. Wednesday, we don't know how many he worked. Write an equation to match the situation. Well, one equation could be like this. 4.5 plus 6.5 plus W for Wednesday equals 16. But we could combine these two and say that this is 10 hours. Here's one more, makes it 11. So we could say 11 plus his Wednesday hours equal a total of 16 hours. And then labeling it, this is Monday and Tuesday. Sorry, I'm going to scroll down so you can see that a little bit more. This is Monday and Tuesday. These would be the Wednesday hours. And this is the total. And again, if it retells the story, you're good. You're gold. All right. I can solve these equations mentally. F plus 6 equals 11. I just like putting the word something in for the variable. Something plus 6 equals 11. Hey, that's 5. 5 plus 6 equals 11. 5 times something equals 30. 5 times 6 equals 30. If you don't know how to do that, you can always turn this around. Something plus 6 equals 11, so 11 minus 6 equals something. 5 times something equals 30. You can take 30 and divide it by 5, and you get 6. Little mental gymnastics for you. All right, rewrite the following expressions using the distributive property. Distributive property, we're going to go from either one set of parentheses to 2, or from 2 sets down to 1 when we rewrite. So let's take a look at here. We have one set of parentheses, so I'm going to make my 2 sets because I know that's what I have to go to. That repeated number becomes the first number. So let me put my arrows in. This would be 3 times 5 and 3 times 2. And the addition sign from there goes right there. So I've just rewritten that. 3 times 5 plus 3 times 2. And this one here Now we got 2, so we're going to go down to 1. And that repeated decimal, or the repeated number, goes out front. So this is 8. Here's my 8 times 5. Here's my 8 times 3. And this is a minus sign in the middle. Okay. All right, so let's keep rolling here. Take a look at a couple others ones. You rewrite the following expressions using the commutative property. Well, commute means to move. So we can just move some numbers around here, but we really can't take them out of the parentheses. So I would rewrite this one as 28 times 5 times 20. Now, yes, you could move the parentheses too, but then you'd be doing the associative property. So, you could also take and move the 20 and write it over here. You can do that as long as you don't break up that 28 times 5, that pairing there. You've only done the associative. You've only done the commutative property. But the minute you move the brackets, then you're using two different properties. Make this multiplication sign a little bit bigger. This one's a little bit easier. 74 plus 13 plus 16. Well, I could just do 13 plus 16. Again, I'm going to keep that bracket and put the plus 74 over here. Okay, or I could rewrite this as 16 plus 13 plus 74. Again, commutative property, we just move the numbers. We don't move the brackets. What's inside there has to stay inside there. All right, rewrite the following expressions using the associative property. Finally, we get to move the brackets. So this one, these numbers will be in the exact same order in its purest form. So I'm just going to move the brackets this time. Easiest way to check for the associative property is just say the numbers. 527, they got to be in the same order. 527, did they just move the brackets? Yep. So these here, I'll write them in the same order. And I'm just going to move the brackets. Let me double check. 8, 14, 6, 8, 14, 6. We are good. That was 1.8c. Those are the properties. Now we're on to back page here. Evaluate using the expressions. Now kids get all freaked out about this. Oh, no, how do you use all these properties at one time? You don't need to use the properties. You can use them to make, if you use the properties, I always tell my kids, if you use the properties, you probably won't have to use a calculator. If you don't use the properties, you probably will have to use a calculator, but this is a calculator test, so it just makes life simpler if you use the properties. So we have 14 times 5 times 2. I don't know what that is, but I do know that 5 times 2 is 10. I can solve it like this. 5 times 2 is 10. 10 times 14, there's my 140. I used the commutative property to move numbers, and then I took and I also used the associative property. I regrouped them. I moved them and regrouped them. I did them both. All right, this one here, 86 plus 29 plus 14. Well, I'm going to do 86 plus 14. I'm going to use that commutative property to move that around. I know this is 100. So there's my 129. Just use the commutative property. All right, 1.10b, use writing. I can write an equation using two variables to represent the function in each of these tables. All right, so what's going on here? How do you go from 1 to 4, 2 to 8, 3 to 12, 4 to 16? It looks like, is it times 4? Let me just try that. It sure is. 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16. So this is my x really, and this is my y. So my y is equal to whatever x is times 4. Now I know you want to write it like this, y equals x times 4, but this is really what we're hoping to get you. This is probably what you're going to see on the test, y equals 4x. Okay? Alrighty, take a look at this another one. I can write the following, I can complete the following function table. Alright, let's see, we've got going 1 to 3. Looks like plus 2. 2 to 5. Nope, that didn't work. So 1 to 3, 2 to 5, 3 to 7. Ooh, this is a tough one, isn't it? But I start looking at the pattern. Are these numbers sequential? They are. 1, 2, 3, 4, 5. Oh, we skipped 6. So let's just think about this. these are going up by 2. So I bet you this is going to be 9, and this is going to be 11. But this one here, we've skipped 6, so we still kind of need to figure out what's going on here. So it's not plus 2, it can't be times 3, so I'm going to try multiplication and addition. What if I said it was times 2, that would be 2 plus 1. You try this, times 2 plus 1. Oh, it's working. Times 2 plus 1. Times 2 plus 1, yep. Times 2 plus 1. So this one would be times 2 plus 1. So this is going to be 15. And that makes sense because 6 would be 13. All right, so let's just think about what that would be as two variable equation. So the y, here's your y, here's your x. The y is equal to 2 times whatever the x is plus 1. And that's just a real popular two variable equation. Identify the domain and range for the table above. Well, it's pretty simple. These items right here, this is going to be your range. So I'll write them down, the range. Put them in a set of brackets here, and we'll just write them down. 3, 5, 7, 9, 3, 5, 7, 9, 11, and 15. Don't slip 13 in there, it's not in there. Put a fancy bracket again. Okay, and my domain will be the x values. 1, 2, 3, 4, 5, and 7. 1. Slide it up so you can see. Sorry. There we go. 1, 2, 3, 4, 5, and 7. All right, last question. Write a two variable equation to represent a function. One variable representing the input, one representing the output. All right, so these ones here I always tell my kids, I start off making a t-chart before I've even drawn it, because I know I'm gonna need a t-chart to make this work. So here's my t-chart, and I'm sorry I can't get the whole question on there, so you'll miss a little bit here. Ray downloads iTunes songs every week. Each song costs $1.55. His total cost, C, dollars. Okay, write an equation to show the relationship between the S songs and the C, the cost. Well, I don't even know what those mean, so I'm just going to put an X and Y to start with. Think about 0, 1, and 2 songs. So if he buys 0 songs, it's going to cost him $0. If he buys 1 song, what are they, $1.55? So that's going to be 1.55. And 2 songs would be double that, so that's going to be $3.10, and so on. So I'm already starting to see what this is. It looks like the Y is equal to whatever $101.55 times the X. Now, I'm already starting to say this, so the Y has got to be the cost. They want the total cost, so the total cost, C, is equal to 155, and then it's times the number of songs. So I always make a table for these. I always go with XY to begin with. It's just very natural for me. I use 0, 1, and 2 if they don't give me any numbers. And then after I've got that, I can figure out my Y equals X statement, my equation for it. And then I substitute in their variables. All right, thanks for listening. Good luck on the test.